we're going over the review sheet today. Huh? Which one? 31? Yep. 31. Okay. Put that down as a reference point. So what we're looking at first is problems 1 through 4. Are there specific questions on 1 through 4? On interval notation with these here. So in that case, I'm just going to look at number 1 for certain. Because whenever we have two numbers and x is in the middle, it means we have two endpoints. It's a bounded interval. So we'll have negative 256, comma, 100. If it's equal to, if it's included, it's a bracket. If it's not equal to, not included, it is a parenthesis. Because the negative 256 was not less than or equal to it, it's a parenthesis since it's just less than. Since it is less than or equal to 100, we have a bracket. So we get this here. I'll look at number 3 next. So x is greater than or equal to negative 174. You can just put it on my desk. Thank you. Now, for this here, it's unbounded. It means we have one endpoint, and it's going to continue indefinitely in one direction or the other. With these, so I can put 174. Now, if it was less than it, it's going to go to negative infinity, smaller numbers. If it's greater than it, it's going to go to positive infinity. Since x is bigger, we're going to positive infinity. Now our bracket's in parentheses. Since it is equal to negative 174, we would have a bracket. Yes. With infinity, will we have a bracket or parenthesis? Right. Can we ever get to infinity? No. Yep. Infinity is always going to have a parenthesis. Always. Huh? It depends on which direction we're going. So here we're saying x is what? Greater. X is bigger, yes? So the bigger one would be infinity. If we said it was less than it, well, negative infinity. Because negative infinity would be less than it. Positive infinity is greater. You can also think of them in terms of a number line. Because it doesn't ask, guys, focus up here. It doesn't ask for a number line. But if we put it negative 174, this would be filled in, and x is greater than, so we're going to the right, which is the direction of positive infinity. The left would be the direction of, and the way we orient them in the interval is always smallest on the left, bigger on the right. So kind of as in terms of the number line. Any other questions on 1 through 4? Questions on 5 through 8? Any questions on 5 through 8? 5. So 5, again, it is flipped, but we're saying which one's bigger, 6 or x? X, because this is the same as saying x is greater than or equal to 6. So 6 is one of our endpoints, and because we don't have another number, it means the other one is either infinity or negative infinity. Since we're talking about it being bigger, we're going to positive infinity. If it had been less than, we would go to negative infinity. And we'll put a bracket with the 6 because it is saying that x is equal to 6. Questions on these here?
What's like the symbol for real numbers?
We just do brace x bar. We use, because the symbol itself is all real numbers, but for set builder, this is saying the set of all real numbers x such that. It's just understood that we use real numbers unless we state otherwise. I'm not going to spend any time on 9 through 14, because 9 through 14, there is 2 problems on the test that cover 9 through 14. They're purely bonus. They're not going to actually be counted against you if you leave them blank. 3. Yep. Part of the reason for that is because, one, I decided to make take those off the test, so I didn't want to include them. And 2, I already had the test printed, so I'm not going to waste paper printing new tests and having those removed. I'm just turning those into bonus, and we're going to move on. Now, if you do want to see how 2 of those work, I did post a video. I posted also a link to it in Google Classroom that has this entire video. I did do 2 of those on it. So if you do want to go back and look at those 2 that I did are closely related to the ones for bonus on the test. So if you want to look back at that, you can. I want to spend more time on the rest of this here. Now, solving systems of linear equations. We have these 2 here. Now, I have a feeling most likely you're going to want to do these in the calculator instead of doing them by hand. If we do them in the calculator, the first thing we need to do is plug in the augmented matrix. I'm going to go on and write the augmented matrix, because if we do this here, our augmented matrix, we need it in the form x, y, z for all the equations, and they always equal the constant term, our number without a variable. And we grab the numbers in front. So we'd have -1 for x, -5 for y, -5 for z, and 2. Our next equation would be 4 for x, -5 for y, 4 for z, and 19. And our last one would be 1, 5, -1, and -20. And it works out this equation is a 3 by 4. So we grab the graphing calculator, clear all this out. We need to first plug the matrix in. So we'll go second matrix and over to edit. We're going to type the dimensions in first, 3 by 4. Now we're going to type those numbers in from our augmented matrix. -1, -5, -5, 2, 4, -5, 4, 19, 1, 5, -1, almost, -20. We get this here. Questions on how we type this in? Some of y'all might find it helpful to write the steps out on the note sheets, because again, you get to use the note sheets on the test. And once we have the whole thing typed in, we're going to go second quit back to the home screen. Second matrix. This time, we're going to find REF and hit enter. But before we hit enter again, we've got to plug in the matrix we want to apply this to. So we'll go second matrix, A, enter. And we get this here. Now on the test, we're not going to have to worry about no solution or infinitely many. I do not put those on the test. So do not put no solution on either of the solving for systems of equations, like problems 15 and 18, because if you do, I will take all points off. Now, when we look at this here, the last column, -2, -3, 3, is the answer. -2, -3, 3. And we're going to write it in this way here as an ordered triplet, because it is the point that all 3 planes intersect.
What did you say? You have to go all points? What?
You put no solution on either one of these on the test, because I do not include them. They are not a part of it. Yes. There's 2 of them. And part of the reason I do that is because, again, I've told y'all several times over, no solution does not work for these here. So I've already told you no solution isn't the answer for either one of these solving 3 variable systems. And if you go on and put it anyways, I've told you it's not it. So we have this here. Now I do give points for doing your work and kind of working them out. I'll still, especially even doing this, you get the points for working it, even if you end up getting the wrong answer. Does that make sense? But I will take those points away if you just put no solution and moved on. Okay. Questions on 15 or 16? You kind of understand how to plug these in, yes? If you do come back later and have questions on these, I do have those on the video. 17, they're the same. 17 is no solution for the review sheet, and 18 is infinitely many. And I'm not going to look at those because they won't show up, so there's no reason to look at them. The one that I did include by hand last year in the years past was the bonus question, but I've changed the bonus question for this year. Now the next ones we look at are these here. Write the augmented matrix and state the dimensions. Are there questions on 19 through 24? Any? Yes. Yes. So we list it out here. Now one thing we do need to make sure is one, they are in the correct order. X, Y, Z. If there's no Z, like 19 didn't have Z in either equation, we do not include it in the matrix. So we do have this here. Now it is a 2 by 3. Now the next one, the middle equation, the Y and X values are switched, and we can see that, yes? Now there's two ways we can do this. The one in the video I did for the full thing, I went on and rewrote it. Rewrote the equation in the correct form. I'm going to look at the middle row first. Well, what is the X value? -7. So the middle row, I can go on and start off and say -7. Then Y is 4/15. I don't necessarily have to rewrite it as -7x plus Y plus 4z equals 15. We can see how to switch it, yes? If rewriting it in the correct form helps you plug it in, rewrite it. Yes, and so that's where we'll go next. So last thing I'll say is if rewriting it as -7x plus Y plus 4z is helpful for you, rewrite it. If you don't need it, you don't have to. I just want to emphasize that point. Right, now the top one we would have 6 for X, but because Y does not show up, it is 0. Then we'd have 4 for Z and 2. And the last one would be 6, -1, 3, 20. If there's not a number written in front of the variable, it's understood to be 1. The only time it's 0 is if it is not there at all. Questions on this here? We good? I would go with the X because I did correct it on some of y'all's assignments that I passed back, but I did not take points off because I didn't fully emphasize that, especially in the lesson. But we do X. X is understood to be by, especially with matrices. 3 by 4. It's used in a lot of different places. Lumber does the same thing. If you've ever looked at a 2 by 4, they actually they'll either put by or they'll put an X for by just to show you the dimensions. But we have these here. Questions on 19 or 20? Questions on 21 or 22? Questions on 23 or 24? So we feel good with writing the augmented matrix and stating the dimensions. Okay, and again, with these here, I'm not asking you to solve any of these here, just to write the matrix and state the dimensions. 25 through 31. So I think we had a question specifically about 31. Now, with this here, so again, do it one at a time. Do it one at a time. The main ones on the test that are dealing with transformations are going to be up, down, left, right. Those are the main 4. There is one on the test that inquires 5 transformations. You're going to do 5 of them, but that is the bonus. That is the new bonus question. I removed the matrix and put that in its place. But even with these here, we're doing it one at a time, just one at a time. So when I look at this here, the first one is a vertical stretch of 3. Yes. Now, when we look at vertical stretch, and especially, I'm not going to take the time to write it out here so we can actually look at more problems. It is in the other video, and I did have y'all write them down off the whiteboard. vertical stretch is our a f of x? Well, a is 3, vertical stretch of 3. So we're just plugging it in place of a. I did add on the whiteboard to flip with horizontal stretch and shrink. We have to flip the value, and we'll see that here in a minute. 3, f of x. Did we change what was inside our parentheses with f of x? No. So what that means is the function doesn't change. We don't do anything to it, so it's still going to be 6x squared minus 2. We just now have the 3 in front. So what we're saying is we're taking f of x, that function, and multiplying it by 3. Now at this point here, we'll distribute the 3. 3 times 6 is, 3 times negative 2 is. So after the vertical stretch of 3, we get the function 18x squared minus 6. Now at this point here, I'm just going to use g of x as a way to name it. I just need to name it as something different than f of x so that we know for certain I'm not talking about the function we started with. That's all g of x, f of x, h of x, q of x, m of x, n of x, any of those is talking about. It's just a way to name it. So when on the test, I'm not focused on this g of x. I'm focused on the function itself. So we've done vertical stretch of 3. The next one, horizontal shrink of 1/4. Horizontal shrink, we flip it, and it's now 4. Now with horizontal stretch and shrink, it says f of a of x, yes? What function are we applying it to? G, yeah? So I'm just replacing the g with the f. So the f isn't really a big deal. We just use it for the main ones over here because I was just applying it to f. We're applying it to g, so it's just g. It's just a name, a letter. Now the a value, that's what's important, is our 4. Questions on this here? Now what did I do this time? Now I replaced the x with 4x. So this x is now 4x, which means every x in the function is now 4x. So everything else stays the same. We'll still have the 18, but now it is minus 6. That's all we're changing. Because we took the x, it was x squared. We don't have x anymore, we now have 4x, but everything else of the function stays put. The 18, the square, the minus 6. So now we have 18 times 4x squared minus 6. For us here, we do not have to square the 4x. I'm not going to make you go through the process of squaring it. I did include that part of the answer. That's why there's 2 answers. I went on in this process, squared it, and showed you what that answer would be. But leaving it as this here is perfectly fine. We good with it? Step 2. Yes. And we can call it h of x. So again, the h of x, g of x, this is just another way to name it. Okay. Vertical stretch of 3, horizontal stretch of 1/4, done. Translation of 6 units. Up. Up and down is our x plus k. Here we'll say h of x plus k. And hopefully, as you're seeing again, pretty much, yes. Now, well, everything's the same. It's just we're changing whatever letter. So the k is, so the one we got done with, the x. Yeah. So we keep, so the question, yes, so why do we keep changing it? Because we want to know which one we're talking about. Which one did we apply it to? Because using just f, I try to stay away from it because we will think we're continuously applying it to the beginning. Well, no, we apply the vertical stretch, then we apply a horizontal shrink to it. Now, the one we applied the horizontal shrink to, we're going to translate 6 units up. Now, h of x, we didn't do anything inside that parentheses. It's still just x, yes? Which means we just grab the previous function, 18, parentheses, 4x squared minus 6. And what are we doing? We're adding, oh, sorry, I about confused everybody. That parentheses is in the wrong spot. Because it should be 4x squared minus 6. I moved the parentheses to the wrong side. Right, because here, technically speaking, we replaced x with x. Well, that doesn't change anything because it's still the same x. So that's why we still have 18 parentheses 4x close parentheses squared minus 6. It's the same function. Now we can drop it. Or x close parentheses squared, because our plus 6 minus 6 is 0. We could write plus 0, but that's not adding anything. So we can have this here. Now normally all the way up to this point we've done 3 is about where we capped out. So now we need another way to name it. C of x. Because I could use C of x, I could use J of x, I could use Q of x. It doesn't matter. It's just another way to name it. Translate 6 units up, and lastly, left 4. So f of x minus h, which in our case we're just saying C. If you want to use, realistically, if you wanted to use f each time, that's fine as long as you keep track of which function you're applying. Now, our h value in this case is what? 4, and it's to the, so it would technically, we plug it in as negative 4, but do we ever leave it? Right. We don't normally leave a negative and a minus next to each other. We rewrite it as a, yes. It's negative 4 because it's going left, but the negative makes it positive. Yes. And that's really inside the parentheses is always opposite of what we think, because earlier we had horizontal shrink of 4, yes? Horizontal shrink of 1/4. Well, we didn't plug 1/4 in, we plugged in opposite, yes? Left, right, going left plus opposite. Especially, no. No. Now, at this point here, just like what we did with the 4x, we're doing the same thing. We're plugging that in every place where there's an. So we have 18 parentheses. Yes, 4x. So 18 parentheses 4x plus 4 squared. We replace the x inside the parentheses with the 4x. It would not be cubed. It'd still be squared. There's one last step. Because I'm not going to ask you to square it. That is a lot. But we will multiply it by 4. Because 4 times x is 4x. And 4 times 4 is plus. And that's the final answer. But again, a problem of this many is only showing up as the bonus. The most of the ones on the test involve one of these or 2. 1 or 2. It's not going to ask you to do more than that on the test. The bonus is 5. And even if you get to the bonus and you get 2 of them or 3 of them, you do get points for that if you don't make it all the way to the last one. Doing only one. 2 with 1, 2 with 2. Questions on any of these here? We feel comfortable with these here, these transformations. If you do realize later that you want to see another one of these, again, I have all of them posted up. It's spread out pretty evenly. There's not a whole bunch of one, and if there are, they're pretty straightforward. Or not, I mean, it's stuff that y'all can do pretty quickly. 31. Yes. Questions on 31? Okay. Yep. I think there was a question on 31, yes?
We just went through it, because ours, 31 on his is 33 on ours.
Yes. Okay. Yeah, I think I made some changes to these and then added them back in. Okay, so that was the 31 we had questions on. Okay. Yeah. Now, again, on the bonus, especially with the 5, I will take those into account. Okay. Questions on these here, performing the indicated operations with matrices. So 31. Yes. So, okay. Now, 30, the answer key, 1/4 of 24 is not 8. Because I think I posted, it's 6. The answer key has 8. You need to change that to 6. It's probably been stated in years past. I forgot to change it on the key on the review sheet. So at the very back, there is an answer key. So when you multiply each one of these by 1/4, you should get 4, 6, 30 over 4, and 9/4. But really 30 over 4 is 15 over 2. Now, if you write one of them as a fraction, obviously 4 and 6 are not fractions. They are simplified as they get. If you put, say, first 15 over 2, I want the other one to be fractional. If you put one of the numbers as fractions, put the rest as fractions. So don't put 15 over 2 and then 2.25. Does that make sense? If you convert one to decimals, convert them all to decimals. If you leave one as fractions, leave the rest as fractions. Questions on 31? Yeah, these two up here. 32 and 33. So we feel comfortable with these two. Now this. So here, there's different ways we can do it. One, we can just plug it all into the calculator, plug each of these matrices as A, B, C, and then type it in as 2A minus 4B plus C. Yeah, because I can name this A, B, C and do it that way. Yes, and I want to make sure we get through, and then yes, if we do have time. If not, I did do both on the full video. Now, if we do this by hand, the first thing I'm going to do is multiply through by 2. 2 times 3 is 6. 2, 8. Okay, now before we move, we feel comfortable with multiplying the first one by 2, yes? Now, there's 2 ways we can do it. One is I multiply everything by -4, or I multiply it by just 4. Either way works. Now, if I multiply it by just 4, it still says minus. Yes. 4 times 8 is 32. 4 times 6 is 24. And 4 times 7 is 28. And what they just said is if we'd have multiplied it by -4, since we took the sign into the matrix already, we wouldn't subtract anymore, we would add. And if you take the negative with it, the sign changes to addition. And if that's a little much, just multiply by 4, leave the negative there. And the last thing we have is plus our 3, 3, 3. Now at this point here, we can subtract the first 2. So 6 minus 32 is -26. 2 minus 24 is -24. And 8 minus 28 is -20. Yes. Yes. So we subtracted the first two, and I, for some reason, just put 24 back down. Thank you. So we're just subtracting each of them. I'm leaving a lot of steps out because, okay, we got about 7 minutes. So we're still good on time, but not great. Now we add 3. Negative 26 to 3 is negative 23. Negative 22 plus 3 is negative 19. And negative 20 plus 3 is negative 17. Because I think the last type is the find the equation line, yes? Yeah. Okay.
You bet.
What's 33? Are you at 34? It's not possible, yes?
Yes.
I will put those on the test because that's more just looking at the matrices. Do they have the same dimensions, yes or no? Yeah, one of them's a 3 by 3, the other's a 3 by 2. If the matrices are not the exact same, we cannot add or subtract. So these two here are pretty much the same thing. We multiply by the number in front and then add or subtract. Same is true with this here. The calculator, if you do plug this in, alpha, the green button, y equals enter. Alpha, y equals enter is fractions. And again, on the test, if you ask y equals, so all the way at the top, almost to the screen, I will tell you again what those are. So green button, go all the way to the top. Last button before you hit the screen is y equals. Yep, and then enter, and you'll get a fraction. Now, for 35 through, well, the last 3 problems, there's 2 parts on the test that you need to find. One is the slope, and second part is the equation of the line. You do not have to interpret the slope or describe it. Find the slope, find the equation. So our slope formula is our y2 minus y1 over x2 minus x1. It did give us a second point on this, the origin, 0, 0. Now for this here, our 2 y values are 33 and 0. Half of it. So the first thing we need to do is find the slope. Plug it into the slope formula. All the ones on the test, I will give you 2 points. You're not going to have to do the rise over run. Questions on finding the slope? Now we just need to find the equation of the line. Yes. All the way at the far. For the equation of the line, we need it in y equals mx plus b. We just need to get y by itself. The y1, x1 is a point. We have 2 of them. It doesn't matter which one you pick. You just got to pick one of them. 33 and 100. So 33 would go in y spot. 100 would go in x. And the slope goes in for m. Now we solve. We get y by itself. So the first thing I'm going to do is we're going to multiply by the slope first. 33 over 100 times x is, well, 33 over 100x. It mostly just gets stuck next to it. Now we're going to do 33 over 100 times 100 times 100 is, it would be. So you can plug it in as negative 100, or we can say minus 33. Yeah. then we would indeed add 33 to both sides. That's it.
Oh my gosh.
You're not having to describe or interpret the slope like you did on the homework. That's all I'm asking for. Questions on this here?
Can we look at the very last question?
Yes.
So would that be 65, 0?
Other way.
0.
Comma 65. Y goes second, x goes first. Now the slope, y2 minus y1 over x2 minus x1. Well, our two y values are 65 and 65. Yep, or x and y. X is always first, y is always second on a point. So 0, 65, x is 0, y is 65.
What?
So 65 minus 65 is?
0.
What times 5 is 0?
0. Yeah.
Y is always up and down. There's not a slope. Now, we can still use this formula. Y minus y1 equals m times x minus x1. 0 divided by 5. Because anything divided by 0, when 0 is on top, it's just 0. If it's the other way, it's undefined. Now, I'm just going to pick 65, 5 as our point. Anything times 0 is, so this entire right side of the equation is exactly. Because whenever we have a flat line, it's just whatever that number is. And that is it. If you do have any other questions, please let me know. All of your homework is due by the end of the day tomorrow. Yes, I got that.
Sir.